Hello guys, and welcome to another video by yours truly, a 1:30 in the morning production. I am this time upstairs, very close to my daughter's room and my wife's room because I had a little toe injury today, and I can't exactly move around that well, so I'm staying on the top floor. I have this up on the screen here because I wanted to show you what's not on the test. That AP said is not going to be on the test. It looks like units 1, 2, and 3, and 4, and 5, and 6, and 7 are on the test, but 8 is not. And what 8 covers is finding the average value of a function, not on the test, connecting position, velocity, and acceleration using integrals, not on the test, using accumulation, and then like integral from a to x or something. And then all the rest of these, 8.4 to 8.12, is all that stuff that we did in the last couple of weeks before we left. The reason I'm bringing this up is because I'm going to talk about position, velocity, and acceleration of functions, but not in terms of integration. I'm only going to talk about it in terms of differentiation. Alright, so let's go ahead and do it. We got recap video number 3, and we are doing particle motion this time. So position is the location of where an object actually is, or an object actually is in a certain time. The different names that they'll give for you is s of t and x of t are the main ones that I've seen. Total distance would be the integral of velocity. Actually, maybe I'll go vertically here. Okay, so the velocity function is going to be v of t, but it's also s prime of t. The acceleration is going to be a of t, but it could also be v prime of t, or it could also be s double prime of t, the second derivative position. The way you can get your total distance traveled, so if an object is going back and forth, the way you can find the total distance that is traveled is just add up all its velocity, but for the negative parts, make those positive as well. Now, this is going to be more useful for you if you have to take calculus in college, because again, the College Board test is not going to be asking you, so that's good. At the integral of the absolute value of velocity is total distance, while the integral of just velocity is the displacement, how much an object can move with while taking direction into consideration. Speeding up and slowing down is a huge one that always comes up every year. I want to mention to you that speeding up is going to be, I did this demonstration in my classes. I think Schwartz also did, maybe not so live. Speeding up is basically if you are traveling in a positive direction and then a force comes and pushes behind you, you end up going faster. So in math speak and calculus speak, we're basically saying if v of t is positive, meaning you're going in a positive direction, and a of t is positive, meaning that there's a force behind you that's moving you even faster in that direction you're going, then in the math speak, we call that we're speeding up. You could say similarly that if you're going to the left, so negative velocity, and there's an acceleration that's pushing you from behind in the left direction, you're speeding up. The most concise way to say this is velocity and acceleration are the same signs. So v of t and a of t are the same signs. One thing I've noticed that students end up making a mistake on is they use velocity to just determine if an object is speeding up. So I want to put a note here that velocity in no way determines if an object is speeding up or not. So let's type this. Velocity is only illustrates direction of travel at rate. It does not specify does not specify whether an object is speeding up or slowing down. Make this a little bit more readable. And I really hope you guys heed that point, because that's going to be a big one. And let's just move this somewhere that we can actually read it. There we go. Historical still. I'm just going to clean this up here. If you could just give me a second. There we go. That is so much better, I guess. Okay, that's better. Okay. So we can say similarly that for slowing down, just writing it out, we would say that v of t is positive, but to slow down, a of t would be negative. Which means that, again, something is going in a positive direction, but there's this opposite force here that's pushing in the opposite direction, causing the object to slow down. We could say similarly again that v of t is negative, so now that it means you're going in a, that's not negative, that means you're now going in to the left. So now you are going to the left, but acceleration here is positive, meaning that your force is going against the direction you're going, causing you to slow down. And a concise way here is v of t and a of t are opposite sides at any time t. Okay, I would take your time to look at this chart. I really don't want to go much on it. I do want to point out, though, that this is small velocity down here, small positive velocity, meaning that you're moving forward. Big positive velocity is up here. Well, that's not really going to help. I think you know that. I don't find that valuable. Let's see. This is a chart that I had a student a couple of years ago by the name of Caroline Crawford. She gave me something like this, and she said it really helped her understand, and I want to just acknowledge her. I think this is Schwartz's writing. I think Schwartz took what Caroline did and just wrote it neatly, as Schwartz does, and consolidated it onto a page to make it worth your while. Again, this is a really, really good idea to note. Please note that the name of this graph is v of t. Now, you also want to note that not every single problem is going to be a graph. So you want to get used to solving this, applying these concepts of speeding up, acceleration, slowing down, acceleration, all of that. You want to get used to that when you're looking at an equation as well, and not just a graph. I think I'll leave it at that because I do have other things to get to. Alright, so let's see. A particle moves along the x-axis. The velocity of the particle at time t is given by v of t and the acceleration of the particle, okay? Which of the following gives the average velocity of the particle from time t equals 0 to t equals 8? So we want the average velocity, we want the average rate of change. Okay. Okay, well, I can tell you number one, it's not this one. It can't be this one because it's total distance. This is the average distance traveled. The reason I know it's not the total distance is because just this part is the total distance, and then divided by that 8 is taking a rate of it, so now it's your average distance. It's definitely not this. You can't just put a half in front to take like an average of velocity. That's not a thing. This part got cut off here. I believe this is supposed to be 8. And again, this is also, oh, I'm sorry, this should be 2 actually. And they're just trying to throw you off with the word average. Average velocity is not your conventional sense, where you're adding something and dividing by the number you have. Okay, so that means it's either a of 8 minus a of 0 over 8. This one tells you your average acceleration. Okay, so that's your average acceleration. So the winner is B. Now, how could the winner be B? Well, let me refresh your memory. as to the integral of 0 of a to v of t. The integral from 0 to a to v of t by the fundamental theorem of calculus is going to be the net change of the antiderivative. The antiderivative of v of t is s, so this is really equal to s of t evaluated from 0 to 8, which is equal to s of 8 minus s of 0 over 8 minus 0. The reason there's an 8 minus 0 there is it was 1 over 8, which was 8 minus 0. This is a rate of change. It's an average rate of change. Right? It's an average rate of change. The reason this is important is because that's kind of on your oral exam. And velocity is just a fancy way of saying rate of change. So they were really looking for an average rate of change. And this one gets it to you. Now there is another formula where you have 1 over b minus a, the integral a to b of f of t dt. That also gives you an average value of a function, which is kind of more of what this problem is testing. But I never try to remember that. That one doesn't help me usually. I kind of unpacked this integral to see what it gave me. Now, here's the best part of this problem. It's not going to be on the test. Okay, a particle moves along the lines and its acceleration is given by a of t equals, okay, if the particle's velocity, great problem, won't be on the test. But I want to show you how to use the calculator for it though. Let's go and get our calculator out if you don't already have it. Clear this nonsense out. Let's go and enter that stuff. Let's go and do, now I learned this cool trick. I think it was alpha y equals. Yeah. Alpha y equals will give you a fraction. Love that one. Okay. Now that's not exactly what I wanted. Okay, let's just type x plus, oh, that's awkward. Okay, let's try that again. Alpha y equals, and I got x plus 3, and at the bottom I have the square root, so second, here we got a square root of x cubed plus 1. Now, this kind of problem won't be on the test either because they said on the College Board that all the problems can be solved without a calculator. This is clearly a calculator problem. But just to give you a little taste of it, I want to just remind you, we do zoom in the standard. Let's see what the graph looks like. Wow, that looks great. This would be your acceleration. It looks like acceleration is always positive here, at least on our window, which is good to know. If the particle's velocity at t equals 0 is 5, what is the velocity of the particle at t equals 3? This is an initial value on velocity. We're looking for the new velocity at t equals 3, so it's a fundamental theorem problem. The way we would work this is I would want to set up an integral from t equals 0 to t equals 3 of a of t dt. Because the integral from 0 to 3 of a of t dt is equal to v of 3 minus v of 0. Your net change in velocity, that's what acceleration is. It's how much your velocity changes. But if I want to solve for v of 3, because v of 3 is what I really actually want, then what I can do is add that v of 0 over, add that initial velocity value over, and I can now get v of 0 plus the integral from 0 to 3 of a of t dt is equal to v of 3, which is kind of what I want. So to do this part of the calculator, v of 0 was 5. That was your initial velocity. So let's go to the home screen. Okay, so let's do 5 plus, now we're going to do the integral, which is math 9, 0 to 3 of, and let's go and do an alpha trace. Alpha trace gets you that y1 menu. And we're going to do a dx and enter that bad boy. 11.710 is my answer. And that's how quick the problem should take. Do not try to solve that integral by hand. Again, if it's a calculator problem, you let the calculator do the work. But this might be a moot point now for the test at least, because again, this won't be on the test. This aspect won't be on the test because it's integrals incorporating position, velocity, and acceleration. For important calculator buttons here, I'm going to allow you to just read those because all of those are really, really important. I'll just write down my favorite ones. Alpha trace gets you the y equals. Alpha y equals gets you a fraction. And by the way, this is kind of confusing. It doesn't get you y equals, but it gets you that menu of y1, y2. I think you know Math 9 is derivatives. Is integrals. And Math 8 is derivatives. Let's see, what else do I want to tell you here about the calculator? The reason I wanted to do this one is because I like teaching the kids the calculator tricks. Let's see. I believe that's it. Yep, I'm going to leave it at that. Okay, guys, hope this was helpful. Schwartz has this page for you in another video. I deleted it already because I didn't want to see it. Thanks for watching. Okay, I got to exit this.